Good morning. I welcome you all to the series of lectures on heat transfer. Today we are going to discuss about the overall heat transfer coefficient and what is the role of overall heat transfer coefficient in heat exchange. Overall heat transfer coefficient is taken when the combined effect of conduction and convection present. Both conduction resistance and convection present. At that situation we are taking overall heat transfer coefficient. For example, let us consider a double pipe heat exchanger. In the smaller diameter pipe, hot fluid is flowing, and in the larger pipe, cold fluid is flowing. Of course, it is a parallel kind of arrangement. Both the fluids are moving in the same direction. So, if I draw the electrical analogy for thermal resistance, so hot fluid inside the, so this is the hot fluid. From the hot fluid, the resistance is there because of the convection, so convection resistance, and followed by because of the wall. This is the wall. So I have drawn somewhat bigger here, but actually it is very thin here, right? For the representation purpose, I have drawn like this. So for the wall, there is a conduction resistance, so R wall, and after the wall, heat is transferred to the cold fluid. So R out. Of course, there is no restriction here. There is no resistance. There is no need to consider the resistance here because heat exchanger is designed by one assumption, that is, heat is transferred from hot fluid to cold fluid. That's it. It is not transferred to the surroundings. So no need to consider any resistance here. So only three resistance: convection resistance by hot fluid, conduction resistance by the surface, this is the surface, and convection resistance by the cold fluid again. So the only three resistance. Now R total resistance is equal to Ri plus R wall plus R naught. Ri, so because of convection 1 by HI R wall log R naught by Ri by 2 pi Kl. So this is the conduction resistance for a cylinder, and R naught again convection cold fluid, so 1 by H naught A naught. So R total is equal to 1 by HI plus log R naught by Ri by 2 pi Kl plus 1 by H naught A naught. Here actually Q is equal to delta T by R total, or you can write Q is equal to UA delta T. U is overall heat transfer coefficient. Both are left side Q, so you can equate the right side parameters. UA delta T is equal to delta T by R total. So delta T get cancelled. UA is equal to 1 by R total, or R total is equal to 1 by UA. So here R total is equal to, you can write 1 by UI AI, that also equal to 1 by U naught A naught, because UI means overall heat transfer coefficient based on inside surface area. U naught means overall heat transfer coefficient based on outside surface area. R total is equal to 1 by UA. UI AI equal to U naught A naught equal to same, this one. Now, if this wall thickness, that means if wall thickness is very less, at that situation, if wall thickness is very less, then R resistance offered by the wall is neglected. R wall is 0. So if R wall is 0, because Ri and R naught both are same, because both almost same, so AI is equal to A naught, because if this wall is very very small thickness, so Ri inside radius equal to outside radius, so Ri is equal to R naught, so AI is equal to A naught. Then this equation become 1 by U is equal to, of course AI is equal to A naught, so cancel AI, no A naught cancelled, and this becomes 0 because R wall is 0, and the equation become 1 by U is equal to, U may be UI or U naught is equal to 1 by HI plus, because AI get cancelled here, plus 1 by H naught, and this becomes 0 because this is equal to R wall. So R resistance wall is 0 because R wall is 0 because the wall thickness is very less. But generally for cylinder, 1 by same equation, 1 by UIA is equal to 1 by U naught A naught, and is equal to 1 by HIAI plus log R naught by R by 2 pi KL, and plus 1 by H naught A naught. Advantage of overall heat transfer coefficient: if we know the values of UI and U naught, UI value and U naught, if we know these values once, then without calculating all the resistance, so no need to calculate all the resistance all the time in the industry. We no need to calculate all the resistance all the time in the industry. We simply calculate heat transfer Q value by substituting the temperature, that is Q is equal to Ui Ai delta T. If you know Ui value, you can calculate heat transfer value, or if you know U naught value, you can calculate heat transfer. Of course, both are same in fact. By just substituting in the temperatures, you can directly get the value of heat transfer, that is Q. That is the greatest advantage if you use overall heat transfer coefficient. No need to calculate all the resistance all the time. If you know values of Ui or U naught once, it is very easy for you to calculate if you know the temperatures. Thank you very much.